Hello, everybody, and welcome back to another lecture in Geography 341, Weather and Society. I'm Dr. Zach Hilgendorf, and this is going to be a bit more of an enjoyable lecture, I think. We're going to talk about some weather folklore. The real reason being, I think some of these you might have actually heard before. Some of them are very famous. Some of them are, you would call them maybe old wives' tales would be the word for it, or folklore, or adages. There's a bunch of different terms for them, but these were basically made, or these concepts were made as a quick and easy way to associate phenomena with reality. So we'll learn some of them maybe are a little bit more accurate than others, but I got like 16 of them here to kind of go over. So let's go ahead and dive into it. And maybe some of these you'll have heard before, maybe some of them you'll use as indicators for weather, because they're not all wrong, actually, as we'll come to find out. All right, so the first one, when dew is on the grass, rain will never come to pass. So there's some truth to this one, although it's not foolproof to predict the day's weather. The dew that we see and feel on grass in the morning is linked to how cloudy the sky was the previous night. As we know and we've learned, clouds can basically serve to insulate the lower atmosphere. So when the sky is clear or mostly clear overnight, the ground cools and warm air radiates away from the ground up towards the sky. If the ground cools enough, dew forms on the grass. When it's cloudy overnight, that ground retains more of its heat and not as much heat is radiated up to the sky. Even the heat that radiates off the ground is reflected back towards the Earth's surface when it hits the cloud layer. This means that dew is less likely to form. So this is somewhat true, partially true. So if you can see rain is on the grass, well, that means that there's not currently a system around you, right? Because that heat will have radiated out and it's not being held in by some type of cloud cover. The next one, cold night, stars bright. Pretty simple, 4 words here. Similar to the last adage, moisture in the atmosphere or in the air tends to dim or redden the sun, redden light from the sun, moon, and stars. Moisture or clouds act as a blanket in the atmosphere and sky, retaining the heat stored in the earth during the day. On nights when there is less moisture or cloud, the temperature will cool quicker and stars will appear brighter because you're not having that vision basically obscured. A halo around the sun or moon means rain or snow is coming soon. I love the rhyming. Uh, so this phrase can often be a decent indicator as to whether or not precipitation's on its way. Why? Well, halos are optical phenomena in the sky that are caused when light refracts off ice crystals in high cirrus clouds in the upper atmosphere. Water vapor in the atmosphere increases ahead of storms, so the formation of halos can sometimes be an indication that some type of wet weather may be approaching. So this one's got some truth to it. You've probably seen this type of haloing that you can kind of see. Here's all around the moon here in this example. Here's another one. If smoke hovers low near the ground, it's likely to rain. It's kind of a relationship. And somewhat true. Smoke particles tend to absorb moisture from the air. The more moisture that's present, the more a particle of smoke will absorb, the heavier that particle of smoke gets. Heavy, moisture-laden smoke particles do not disperse as easily as the drier ones do, so it hugs closer to the ground. So there, that's saying that there's a lot more moisture in the air, so there's obviously the potential that there could be some type of system developing, or that at least there's moisture in the system for that storm to maybe develop in the future. When leaves turn their back, 'tis a sign it's going to rain. Um, so this is somewhat true. Some trees, such as oak and maple, have leaves that will curl when humidity is very high and the wind is blowing strongly. Both these conditions can pretty decently indicate that there's a storm approaching. So there's some truth to this one. So learn your trees and look at oaks and maples, and you can tell the weather, at least to some degree. When sound travels far and wide, a stormy day will betide. Again, somewhat true. Sound travels at different speeds through different substances. It travels faster through a solid substance than it does air, for instance. Sound travels better in air that is heavily laden with moisture than it does in dry air. So if there's, again, a lot of these deal with how do you determine whether or not there's moisture in the air? And if there's moisture in the air, well, then there's much greater potential for storms. So that's kind of what a lot of these revolve around. If birds fly low, expect rain and to blow. When the air pressure is high, it's easier for birds to fly at a higher altitude. If the air pressure is low, indicating bad weather, birds can't fly as high because the air is less dense. So again, some truth to this one, but I guess I haven't watched birds enough to observe if certain species are flying higher or lower. So you might have to become a birder if you want really to use this one pretty accurately. If salt is sticky and gains weight, it will rain before too late. Again, I love the rhyming. Will draw in moisture from the air. When humidity is in the atmosphere, or when humidity in the atmosphere is high, it's oftentimes an indication of rain. Salt will soak up the moisture in the air and can actually clog salt shakers up. So that one, there's again some truth to it. If it's humid enough to make salt stickier, then well, it's kind of a good indication that there might be a lot of moisture in the atmosphere. So, not myth busted. If you're a fan of Mythbusters back in the day, we wouldn't have the busted. We'd have like plausible here maybe. This is one that I grew up with, hearing all the time. Red sky at night, sailors delight. Red sky in morning, sailors take warning. Phrase does have some scientific meaning behind it, and we actually learned about it way back in the day. I think maybe week 3 or 4, where we were learning about fates of insolation. So fates of those rays of the sun, incoming solar radiation, as it moves through our atmosphere. And one of them was the Rayleigh effect. So when the sun is setting, light is passing through a thicker part of the atmosphere compared to the sun when the sun is directly overhead. When the sun is directly overhead, we see that expressed as blue light, because obviously everything else is being kind of reflected back. When the sun is coming in at a lower angle, obviously those waves we see all the rest of the stuff reflected except for red light, or reds and oranges and yellows. So where does the sailors delight and sailors take warning part come in? Well, think of how systems in these mid-latitude systems in the northern hemisphere function. Red skies at night suggest that clouds are to the west. And if we think about the dominant rotation of a mid-latitude cyclone, kind of counterclockwise, right? This way here. Well, if your clouds are in the west over here, well, that system might have already passed you if you're right over here. But if those clouds are in the east, well, maybe those are going to be coming your way. So that kind of suggests that red skies at night, the weather might have already passed. Red skies in the morning, well, that means that storms could be heading your way. Obviously, in the northern hemisphere, we have that type of counterclockwise rotation. So that this one is absolutely plausible, and is kind of a good way to consider that and consider storms. But again, not perfect, obviously, but a pretty good indicator. When the icy wind warms, expect snowstorms. This one's kind of straightforward, actually. As air warms, it's got a greater moisture capacity and it can produce larger storms. So if you've got an icy northerly wind blowing down at you and it starts to warm up, some southerly or southerly winds start to creep in maybe a little bit. As long as that moisture is there, you can create storms that have a chance for much larger deposition. So, it's some of the biggest storms that I can remember have happened when we've had conditions around, 30 to 33 degrees Fahrenheit, around 0 degrees Celsius, right? Right around that freezing point, because there's that much more moisture in the air, and snow takes up much more space than rain, and you can have, 2 feet of snow falling on you before you know it. No weather is ill if the wind be still. Seems like something a sailor or a pirate should say. Here, calm conditions, especially with clear skies, indicate the dominance of a high pressure area. Because highs are broad regions of descending air, they discourage the formation of phenomena typically associated with weather, like clouds and wind and precipitation. Calm conditions, though, may also result from a circumstance known as the calm before the storm. You've heard this one before, in which a large thunderstorm cell to the west may be updrafting the westerly surface winds before it can arrive locally. This situation is readily identifiable by looking to the west, for example. Such an approaching storm will be close enough to be unmistakable. In winter, though, calm air and clear skies may signal the presence of an Arctic high, typically accompanied by very cold air. And it's difficult to imagine describing a temperature of negative 35 degrees Celsius or negative 31 degrees Fahrenheit as pleasant. So obviously this one's got some truth, but it's kind of more on the kind of side. Mare's tails and mackerel scales make lofty ships carry low sails. Uh, Mare's tails we know as cirrus clouds. Mackerel skies we know as altocumulus clouds. They appear broken and scaly. Neither of these cloud types will bring rain or snow themselves. However, as we learned in the cloud lecture a good number of weeks ago, they do precede an approaching storm front by a day or two. So you see these, you know that you don't want to have your sails up. You have low sails so that you're not getting blown off course, so that you're sailing maybe with the current rather than with the wind. So that's where that one kind of comes from. But we're not necessarily always on the high seas. But if you see cirrus clouds and you see these mackerel scales or altocumulus clouds, that can be a good indication that a front is moving in soon. Pale moon rains, red moon blows, white moon neither rains nor snows. This one, again, it's kind of easy to understand. The more dust particles that are in the air, the greater the chance that moisture will have something on which to form raindrops. Drops of rain can't form unless they have a condensation nuclei. We've learned about that, which is a dust particle, an ice crystal, or some similar tiny particulate. When moonlight passes through the air laden with dust particles, it appears pale or reddish. When the air is very clear, it appears white. So pale moon is moon that's maybe a bit more obscured by water particles, water vapor. Red moon is a moon obscured by entrained dust, and a white moon is signifying clear conditions here. You can tell the temperature by counting a cricket's chirps. This isn't really an adage, it's more of like a rule of thumb, I guess. So this one's interesting because cricket chirps are actually kind of relatively accurate indicators of temperature. I mean, it's easy to understand why. They chirp faster when conditions are warmer. They chirp slower when conditions are colder. And you can count their chirps, and basically you count their chirps for 14 seconds, then add 40, and you kind of have a decent indicator of what temperature it is, at least in Fahrenheit. I've never done this before, and I think I'm going to have to try it once the crickets really get out this season. So try it yourself once you start to hear crickets, but kind of an interesting one, I think. And then our last one, this is one I also grew up hearing. Do the stripes on the back of a woolly caterpillar indicate the severity of an upcoming winter? Now we can look at here, large black stripes with a thin, rusty red stripe. Harsh winter, the more black, the more harsh. If we have kind of equal third, moderate winters. If we have a lot of red and little black, mild winters, the more brown, the more mild. Winter, if we get down there a little bit more, it's kind of offset. Winter begins harsh and ends mild. This is getting absurd. And then if there's more black near the tail, winter begins mildly and ends harshly. These are fascinating little meteorologists, aren't they? So the legend has basically been popular amongst those living in New England and the Midwest for quite some time. You've probably heard this growing up. The markings on a woolly bear caterpillar are supposedly foretold the types of winter that are going to be had based on the size of that black stripe. Legend stated that the longer the black bands were on the woolly bear, the snowier, colder, and more severe the winter would be. Similarly, prediction of a more mild winter followed if there were a larger number of brown bands in the middle stripe of the caterpillar. Unfortunately, there is nothing that suggests that this is true. Whatever that does for your childhood memories of woolly bear caterpillars, I apologize. But the size of those stripes partly depend on age, so the banding can actually be an indicator of the recent growth of the caterpillar. So much more than their ability to innately understand the potential winter that is approaching. So that's the last one, of course, is our 15th one that we looked at here. So in this video, we just kind of talked about some fun folklore. In the next set, so starting next week, our final week, we're going to be learning about kind of weather in a changing world. And now we've talked about forecasts and we've talked about all the different aspects of interpreted weather. Now we're going to learn a little bit more about where weather could be going in the future, and it's got an interesting future ahead of it. So I hope you enjoyed that one. It was very fun to research and very fun to learn about all these different weird adages that we've used throughout history. So I will see you in the next video, and I hope you have a wonderful week. Thank you.